Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good and safe. And today let us discuss about the BGP. BGP is a Border Gateway Protocol version 4 which provides a inter-domain routing. So which is used to route between different autonomous system. So since internet is a collection of interconnected autonomous system, so BGP is a best routing protocol which is used to route between different autonomous system, and it utilizes TCP for reliable transfer of packet on port 179. So what is an autonomous system? It is a collection of routers under a single administrative domain, and each and every autonomous system are assigned an autonomous system number, which is a 16-bit number ranging from 1 to 65535. So now let us understand the difference between IGP and EGP. So IGP is a interior gateway protocol which is used to route within an autonomous system. An example is RIP and OSPF. So EGP is used to interconnect different autonomous system, or it is used to connect two different autonomous system. An example is BGP. So EGP is a historic routing protocol and BGP is a successor to EGP. So when to use BGP? When there is more than one ISP and when the customer router support BGP, then we have to use BGP routing protocol. So when not to use is when there is a single ISP and when the customer router does not support BGP, there is no need to use BGP protocol. So what is multi-homing? It is used to increase the reliability of the connections to the internet and to increase the performance of the connection. So how we can increase the reliability? So when the customer router is multi-homed with two ISP, right? ISP1 and ISP2. If a single ISP goes down, the customer router can utilize the ISP2 as a backup service provider. And also customer router can use better path to reach destination, either ISP1 or ISP2. So in both this way, we can use multi-homing. It is used to increase the reliability and the performance of the connections to the internet. So there are three ways we can use multi-homing. First scenario is each ISP passes a default route to the customer AS, right? So in that scenario, the customer router will install the best metrics, or you can use the least IGP metric to reach either ISP1 or ISP2. And in the second scenario, each ISP passes a default route and a provider own specific routes. That is a route owned by the service provider, right? So in the second and the third scenario, the customer router has to run BGP or IBGP on all the routers within a single AS, right? So because if the customer router is running IGP, say it is an OSPF or EIGRP, so the customer router has to handle the entire BGP internet routing table, right? So always the best scenario is you have to run IBGP on all the routers within a single autonomous system. So in the second and the third scenario, since the second scenario is each ISP passes a default route and the provider owns specific route from ISP1 and ISP2 to the customer router, and the third scenario is each ISP will pass the entire routing table. So the customer router should have the capability to support all the route, right? So always better to run IBGP on all the customer routers within a single autonomous system. So what is IBGP? So the BGP running between the routers within a single autonomous system we call it as an IBGP. So IBGP relationship are formed through neighbors. So it is not between the neighbors, it is always formed through neighbors. That means we have to explicitly configure the neighbor statement for each and every router. So each and every router will be in a full mesh neighbor relationship with all other router. So that is the main purpose. IBGP are not between the neighbors. IBGP are always formed through neighbors. So what is an EBGP? So the BGP running between routers between the two different autonomous systems, we call it as an EBGP. So we can peer either using a directly connected interface or we can peer using a loopback address. So EBGP can be reached by a directly connected network or by using a routing protocol. So what are the BGP tables? So BGP topology table and topology database. Another one is BGP routing table. So always BGP utilizes a TCP three-way handshake with the neighbor. So it always forms a TCP three-way handshake with the neighbor. And once a neighbor relationships are established, the entire neighbor information will be contained in the topology database or the topology table. So the topology table contains a summary of all the BGP neighbor relationship. So once the BGP neighbor relationship is established, it will start sharing the updated information like prefix and NLRI. So what is prefix is nothing but what are the networks it is going to advertise to the neighbor, and NLR is nothing but a network layer reachability information, which we call it as a path attributes. So the BGP, they have defined several path attributes to control the routing updates. That means we can influence the inbound or outbound path using this NLRI. NLRI is nothing but a network layer reachability information, which we also called as a path attributes, that is used to control the routing. We can also influence the inbound and the outbound path using the BGP. So BGP is a policy based routing, or we also call BGP as a path vector protocol. So let us understand the difference between BGP neighbor and the network statement. So in other routing protocol, we'll use only network statement, right? So using the network statement, it will exchange the hello packet. So once the neighbor relationship is established, it will start sharing the updated information, right? So that is the case with EIGRP and OSPF. But in case of BGP, so we'll use a neighbor statement for establishing the TCP three-way handshake with the neighbor. And once the neighbor relationship is established, we'll advertise the prefixes and the path attributes. So that we are doing using the network statement. So the network statement is only for what are the prefixes which you are going to advertise, right? So that is the difference between BGP neighbor and the network statement. So let us understand the BGP messages. So the first message is sent is open message, so which contain version. Version is version 4, and BGP router ID selected by the router with the highest IP address or the loopback address and the local AS number. So it is the first message it will send between the neighbors to initiate the session. So once it receives a reply open message from the peer, it will periodically send the keep alive messages every 60 seconds to ensure that the remote peer is always available. So once it receives a reply keep alive message from the neighbor, it will start sharing the updated information. So the updated information always contain right prefix and the NLRI, right, path attributes and the what are the networks it is going to advertise between the neighbor. So notification messages are always sent when there is an error, right? So mistakenly if you are configuring any incorrect neighbor statement, so it will be sent in the notification will be sent in the form of error. So now let us understand the BGP state. So the first is the idle state, that is the initial BGP state. So then connect is nothing but BGP will wait for the TCP connection from the peer, or the BGP will attempt to initiate a TCP connection with the remote peer. So once the connection is established, it will send a open message, right? So the open message carries information like version, router ID and other information to the peer. So once it receives a reply open message, it will send a keep alive and a reply keep alive message. So that we call it as open confirm. So once then establish nothing but once it is done, the BGP session will be fully established and it will start advertising the prefix and the path attributes between the neighbors. So these are the BGP states. So now let us understand what is a transit is, which is used to route traffic from one ISP1 to ISP2. So this ISP1 can use customer router as a transit path to reach ISP2, or ISP2 can use a customer router as a transit path to reach ISP1. So that is the purpose of transit autonomous system. So what is a non-transit autonomous system which will not route traffic from one ISP1 and on another ISP2, right? So in that scenario, we have to run a full mesh IBGP neighbor relationship. That means all these routers will run a full mesh IBGP neighbor relationship. Each and every router will be in a full mesh relationship with all other router within a single autonomous system. So always the non-transit AS we have to run a full mesh IBGP neighbor relationship. Why? Because whenever the router receives any information from the external autonomous system, external ISP, so this will be responsible for updating all other information. So each and every router will be having a complete understanding of external routes. So that is the main purpose. In a non-transit AS, we have to run a full mesh IBGP neighbor relationship within a single autonomous system. So now let us go to summary. So BGP provides a inter-domain routing which is used to route between different autonomous systems. So IBGP is nothing but BGP running between the routers within a single autonomous system. EBGP is nothing but BGP running between the different autonomous system, we call it as an EBGP. So BGP always utilizes a TCP three-way handshake for establishing the neighbor relationship. Show IP BGP all summary will show the detailed summary of all the neighbors. So for advertising prefixes and path attributes, we can see it in show IP BGP. So this is nothing but a routing table and this is nothing but a topology BGP topology table. I hope you understood. Thanks for watching. Please subscribe me for more videos. Thank you. Have a wonderful day.